Okay, so this is still, I am videoing, by the way. So this is still 6-1 still practice, and we're on number 6 right here. And number 6, we do exactly the same way that we did number 4 and number 5. So you're going to set up your little equation where you've got 180 times 2, n minus 2, divided by n, and that's going to equal whatever they gave us. And what they gave us was 150, right? So now to solve that, all we have to do is basic algebra stuff. So we're going to multiply both sides by n. Multiply by n there, multiply by n there. Those n's are going to cancel. Is that okay with you guys if we go ahead and do the distributive property right here? Is that all right? Instead of writing it down and then doing distributive property and rewriting it. So if we do 180 times n, that's 180n. And then 180 times negative 2 is negative 360. And then over here we've got 150n. Okay, so what's our next step going to be? What do we do next? Subtract that 180n. So minus 180n from both sides. What's 150 minus 180? Negative 30. So we've got negative 360 on this side and negative 30n on this side. What's our next step? Not add. Divide. Divide by what? Negative 30. So what is negative 360 divided by negative 30? I think you plugged something in wrong.
Negative. Oh, I forgot to put a 0.
What? You have a calculator in front of you. 12?
Yeah.
So what that means is a polygon that has 12 sides, if it's a regular polygon, each angle is 150 degrees. Okay? What is a 12-sided polygon, by the way? What's it called? What do we name it? You're on top of it. Not a 12-agon. I mean, we could call it a 12-gon, but it's a dodecagon. Dodeca. Okay. All right, so here we have a diagram of a quadrilateral. Now, we're going to do a little cheating on this one. What do we know the interior angles of a quadrilateral? What's the sum of those interior angles? Of all of them? 360. We know it's 360. Like, we know that. So we're going to take a little shortcut on this one and not do the math on it, okay? So we know it's 360, and we know that's for all 4 of those angles. So if we add up this angle plus this angle plus this angle plus this angle, it has to equal 360 degrees, right? Now, since these two are the same, we don't have to write down 2x minus 15 plus 2x minus 15. We can just do 2 times 2x minus 15. Y'all see what I'm saying? So we can do 2 times 2x minus 15 plus, and then what are these two? 2 times x, which is what? 2x, right? And it has to equal 360 because that's what the interior angles of a quadrilateral add up to. Now we can just solve this and find x. So what's our first step going to be? What do we need to do first to solve that? Distribute, right? We need to do the distributive property. So 2 times 2x is 4x. 2 times negative 15 is negative 30. What next? What should we do next? What? So add that 30. So we can totally do that if that's what y'all want to do. So we'll add 30 to both sides so we move it. So what does that leave us over there on that side? I'm going to have to jump over here. So 4x plus 2x equals 390, right? Now what? Add these. Combine these like terms and get 6x. Now what? Divide by 6. And what is x? 65. Now, is that our answer? No. So we still have to go back in, right? And so now it is going to be our answer here. That's going to be 65 degrees. That's going to be 65 degrees. But here we got to do some math, don't we? So we have to do 2 times 65 minus 15. So what would 2 times 60 be? Well, what's 2 times 6? 12. So 2 times 60 is 120, right? And then what's 2 times 5? 10. So 120 and 10 is, what's 120 plus 10? 130 minus 15. 115. See how we can do that math in our head? So that one's 115. So is this one 115? When you do your practice page, I've set it up to where you put the angle answers at each angle. Okay? So you'll calculate the angle measurements and then put the angle answer in that angle box. Okay. I'm not going to do 8 and 9 because they're exactly the same thing. You're doing exactly the same process. Okay? We will do 10 together though because 10's different. What makes 10 different? Huh? What's different about that one? The shape. It's not a quadrilateral. It's a what? How many sides does this have? It has 6 sides. It's a hexagon. Now, I know you have your little chart. You could go back and look at your chart. We probably have it on there. But we're not going to do that. We're going to pretend like you don't have your chart. Because, like, if you're taking the ACT Aspire, you're not going to have a chart to go look at, right? So, what we're going to do is we're going to calculate the sum of those interior angles. Now, remember, that's what we learned yesterday. How to find the sum of the interior angles. So, what's our process to do that? How do we find that? What was our little formula? So we have 180. And then what do we multiply 180 by? How many triangles, right? And how do we find how many triangles? So we're going to take how many sides? How many sides is there? 6. And we do what to that number? Subtract 2. So that's going to wind up being 180 times 4 is what that winds up being. Okay? So, does anybody know what that is? Y'all have calculators. Use them. 720. So that tells us that all of these angles inside here add up to 720 degrees. So if we want to solve this, we'll just add up all the angle measures and set that equal to 720 degrees and then solve for x. Now, we could write 7x plus 7x plus 4x plus 7x plus 7x plus 4x. We could do that, right? Or, how many 7x's are there? There's 4. So we could do 4 times 7x, because there are 4 of them, plus, how many 4x's are there? 2. So we could do 2 times 4x, because there's 2 of them. And what does that have to equal? 720. Okay, what's 4 times 7?
24.
Almost.
Oh, 28.
28. What's 2 times 4?
8.
8. Okay, so what is 28 and 8? 36. Good. What is 720 divided by 36? Because that's our next step, right? It's 20. So, X is 20. Is that the answer? No. What do we still have to go back and do? What do we got to do to find the actual answers? So we're going to do 7 times 20 and 4 times 20. What's 7 times 20? 140. So every one of these angles that have 7x are 140, right? 140 degrees. We got to put a degree symbol on them. Those are angle measurements. And then what is 4 times 20? 80. So every one of these angles that have 4x are 80 degrees. Those are our answers. Does that make sense? Okay. Let's look at the next little bit here. So we're looking for the measure of each interior angle of a regular polygon. Now, regular polygon means what? What does that mean if it's regular? What did we say that meant, though? What does regular mean?
Pardon the interruption, teachers. Everyone, please make sure you are checking roll every period today. Y'all know we've got a lot out, so please make sure you are checking roll. Thank you.
Okay. What is a regular polygon? What makes it regular?
It has 90 degrees.
Not 90-degree angles.
80.
No. No. What is it when you think of a regular polygon? What is it?
It's a triangle.
Okay, all the angles are the same. If it's regular, then every angle in it is the same. Every side is the same length. Every angle is the same. Okay? So a regular quadrilateral, all 4 angles are going to be the same. Now, what is the sum of the angles of a quadrilateral? What do we know they add up to? 360. If there are 4 of them and they're all the same, how do we find out what one of them is? Divide by 4. So we would do 360 divided by 4, and that gives us 90. Now, it makes sense. What quadrilateral has all 4 sides the same?
Square.
A square. And angles the same, a square, right? And what are the angle measurements of a square? 90. Right? So it is logical. Okay? What about on a pentagon? Now, once again, I know that you have your handy-dandy little chart, and you could just look it up. But we're going to pretend like you don't have it, okay? So how do we find all the angle measures in a pentagon? Well, we would do 5 minus 2 times 180, right? So we would do 5 minus 2 times 180. So it's going to be 3 times 180, which is 540. And then how many angles are there in a pentagon? 5. So if they're all the same size, we'll take 540 and divide by 5. And we'll get what each individual one is. 108. And that's our answer, right? Okay, so if we look at dodecagon. Dodeca? 12.
Oh, yeah.
So think of it like this. Do, that's 2. Deca, that's 10. So 10 and 2 makes 10 and 2 make 12. Okay, so it's 12, right? So we're going to find the sum of all the interior angles. We're going to do 12 minus 2 times 180. We learned that yesterday. That's not something that I'm just throwing out there for fun of it. We learned it yesterday. So that's going to be what, 1,800? And then we're going to divide that by, I don't know what I've got going on in here. Hang on. My brain and my hand didn't cooperate for just a second. We're going to divide it by 12. Why 12? There's 12 angles. Okay, so what does that give us? 150. So every angle inside a dodecagon that's regular, which means all the sides and all the angles are the same, every angle is 150 degrees. So far, so good? Okay. Now, I need to teach you a little something that's sort of not on this sheet for just a minute. I'm going to do it over here. So if I have a triangle and I extend each side out like this, you can see the exterior angles of that triangle, right? They're always there. We just don't always look at them, right? Now, if I go from here to here, that's that angle measure, correct? And if I go from here to here, that's that angle measure, right? And then here to here, that's that angle measure, right? So I went all the way around. What is that? And how many degrees are in a circle? 360. So how many degrees do those external angles add up to?
4. What?
Okay, we went all the way around. And what y'all say that was? How many degrees is that all the way around? 360. So what do these three exterior angles add up to? 360. 360. They add up to 360 degrees. Because this plus this plus this makes a circle. That's 360 degrees. Y'all see what I'm saying? Okay. What if I use a quadrilateral and I extend it out? Like so, right? And then I said, hey, if I go from this angle to this angle to this angle to this angle, what does that make? 360. Guess what the exterior angles of a quadrilateral equal? 360. So the exterior angles equal 360. Right? Okay. What if I draw a pentagon? So a very poorly drawn pentagon, but a pentagon still, right? And I extend each side out. Right? And then I go from this angle to this angle to this angle to this angle to this angle. How many degrees is that? Y'all think this is going to happen every single time? Yes. It doesn't matter how big your shape is. It could be a 20 gon, 100 gon, a 4,000 gon. Guess what all the external angles will always add up to? 360. Well, that's not a polygon, so that's irrelevant. It's not a polygon. So, if I have a regular octagon, how many sides is that? Octagon. 8. How many angles? Internal angles.
8.
So guess how many external angles?
8.
8. And guess what those external angles add up to?
8.
They add up to 360 because every single shape's exterior angles add up to 360. So, if it's regular, that means they're all the same size, right? So I can do I can do 360 divided by 8, and that will give me what each exterior angle is. What is 360 divided by 8? 45. So each exterior angle is 45 degrees on a regular octagon. Okay? What about on a nonagon? So on a nonagon, what do they add up to? There's the 360. How many of them are there? There are 9. So if we divide by 9, that's going to tell us each one is 40 degrees. You'll see how it works? Okay. What about on a 12-gon? By the way, what do we actually call a 12-gon? What's its name? Dodeca. Dodeca. So on a 12-gon, what do they all add up to? 360. Now remember, this is exterior angles. Only if we're talking about exterior angles, right? And we divide by 12, what do we get? So each one is 30 degrees. That's it? Now, I do want to show you a little shortcut. Let's say we have a, I'm just going to do I'll just do a triangle. That one's easy. So we got a triangle, right? No, I'm not going to do a triangle. Let's say we have a pentagon. Right? And we know that the outside of the pentagon is 360. And we know it's a regular pentagon because all these sides are the same. And so we do 360 divided by 5, and that gets me what an exterior one is. What is that? Somebody do 360 divided by 5 for me. I don't know what it is. It's going to be 60-something. 72. I was totally wrong. Okay, so it's 72. So that means this exterior angle is 72 degrees. Right? What do these two angles have to add up to? 180. So if I know my exterior angle, to find my interior angle, all I have to do is 180 minus 72. So 180 minus 72 gives me 108. And we know, because we've done the pentagon a bunch of times the last 2 days, we know that 108 is the correct answer for that. So you can find your exterior angle to find your interior angle if you want to. Okay? Okay, so you're going to work on your practice. You do have an interactive worksheet on Google Classroom to put in your answers. If your answer is for an angle measurement, you have to put the degree symbol or it will be counted wrong. If your answer is not an angle, it's how many sides there are, okay? Don't put the degree symbol or it will be counted wrong. Pay attention to what you're answering. Does everybody understand? Okay, I think y'all still have enough time to get done.